Hey Jackie, what are we discussing today?
Hey, Nikkei. So today we'll be discussing transformers, and a really important concept within transformer is self-attention.
So, what about them?
So the reason we're talking about transformers and self-attention, and there are more concepts which we'll be talking in this series, is a lot of times we have seen designers and most of the people, they've been prompting AI, and we've seen how they have been expressing that AI is not fetching them the right response. Sometimes I would say that there are some capability constraints within LLMs, but majority of the time it's because we are really bad at prompting. And most of us actually don't know why it's important to write a good prompt. Knowing about transformer, which is the core brain architecture, which most modern LLMs use to read and generate the next words. And the self-attention will help them, and being mindful about creating a good prompt, having more clarity in how they express to the AI.
So, let's just understand the concept of self attention more clearly.
Self-attention is a mechanism that decides what each word should look to understand meaning.
So, it's more like every word, the model calculates which other words are useful right now.
100%.
So, you mean that paying attention is like how I pay attention in the meetings?
You're in meeting? Yeah. Except there's no guilt involved, and it's not listening. The first thing we need to be very careful. In
Right.
the meetings, you listen to what others are saying. Here, the model is basically computing. There's a key difference. So just think about it's in like auto layout engine for meaning.
Auto layout for meaning? What does that mean?
Let's take an example of a design file. In a design file, components don't just exist. It needs constraints. For example, an icon belongs to this button, a label belongs to some input. So everything is constrained around certain thing. So you can think self-attention relates to what you're actually defining, and it then tries to figure out what the intent of the user is.
But I had a question. How does it decide like what particular keyword or let's say a component to pay attention to?
Okay, it does a scoring game. For example, so there are like key concepts called query, key, and value. The query intention is like it decides like what am I looking for. Key will be centered around what do you contain,
Yeah.
right? And the value is if this information matter, what information should I take?
Yeah.
So then it weights words based on how relevant they are. So this is how a simple transformer architecture is. Now you see
Yeah.
here, so there is this input
Yeah.
and output. What
Yeah.
we're talking is this input right now we give as prompt. So now if you see here, once you define your input, the first thing the transformer does is to understand what are you trying to say, so it can bring the right response. And here you see this encoder piece. Here you see this self-attention as a key concept within the encoder. Now this self-attention job is to understand meaning prompt. And once you understand the meaning, it passes to the decoder, which we'll talk in later how it works.
Okay, I think this seems a little technical for those people who are learning this concept for the first time. So let's just take a real life example. So a particular word light can be used in different scenarios. First could be around use light font weight in captions. Second scenario could be this phone that I have is of very lightweight. This could be another example.
Now, if you see here, for a normal person, it's very easy to understand that this light, although both use the same word, but the meaning here is totally different for both the sentences. So what it has is like two words but two different meanings.
Yeah.
So how would a model know what it means? Because they are not human. Everything is math. So to understand meaning of light is different. What it uses is self-attention helps model decide which meaning to use by looking at the nearby signals. So in the first sentence, it might take a signal like font and weight, and it immediately decides that this has something to do on topography. And in the second one, the signals could be phone and carry, and it knows that it has to lean towards physical weight.
So you mean the words around light are acting as a context anchors?
Perfect. This is the right word. These are context anchors. Context anchors are the exact reason why prompting matters for designers.
You're right. That's what we do. We give anchors to the model in order for the model to understand it better. Let's say if we're giving like very vague prompt, not so detailed, then the model would actually guess in that case. And if somebody, they're writing a prompt in a very detailed, they're writing all the nuances around the context, then the model will definitely lock in and would give accurate results.
You're right. If your anchors are weak, your model will start guessing. And if our anchors are strong, which means we really did a good job in defining the prompt, then you will be able to get better responses and accurate responses from the model.
Now, I think let's just take a real life example. To be a design engineer, you really need to ace the game of vibe coding. And what happens in vibe coding is, my God, I have suffered a lot. I remember this one day where I was vibe coding with Cursor, and I was creating an application where I had to just simply, change the color of a primary button. And I was giving prompt to the Cursor that make the button primary. Now, what is primary? Like, primary could be in action, primary could be in color, and that day my all tokens were exhausted. So I can actually feel and empathize with those people who are vibe code. They think that they're vibe coding, but they're actually not vibe coding because they're not telling the nuances around the context.
100% right. Even when you say like make the button primary, the model will eventually start guessing as like, are you talking
Yeah.
about primary color? Are you talking about primary action? Or like
Yeah.
primary in a design system component set?
Yeah.
So
Yeah.
anything can happen, right? So
That.
even I'm guessing right now when you just say like make the button primary. And the problem is that if you give the same instructions to an intern, they will even be confused.
Right.
So now let's see how we can make this as a better prompt. What if we write the same thing like make the button primary, but we write few more anchors like primary action for checkout. Use the design system that we have and use the button primary and use the large. So now see how many signals are we putting out there. We're saying it's a button. We're saying it's an action for checkout. We are asking it to do like design system. This becomes a signal, button, primary. And then lastly, we have large. So now the model has more tokens that it can attend to the narrow meaning. Ultimately, what each of words are what token. If you want to know more about token, you can go and see our video where we have explained about what tokens. So in a single sentence, if you're saying like what's a prompting? So prompting is placing right labels, right places. Which means
Exactly.
if you start defining your prompt, but you have been careless about articulating it, which means maybe you have used certain words at a different place, then model will start getting a different meaning out of it.
Right. It'll start hallucinating and it'll start guessing, and eventually you'll not get your desired result. Now, let's just come back to the transformer architecture and understand why the position of tokens are so important. Transformers reads tokens parallelly, not like old models where they read from left or right. It doesn't read tokens sequentially. It requires a special signal which we call as word order. That's what positional encoding is, which captures location of tokens, and without positional encoding, it will never know which tokens are placed at which point.
100% right. So it doesn't naturally know like left to right how the words are arranged without this position info. It's like a designer who is dumping all the UI components in a canvas, right? Think, can you get any meaningful information out of it? Let's say we have a dashboard, like fitness dashboards. Ideally, a person would want a few KPIs in the top chart. After that, that shows like how he has been progressing his health, maybe a few more charts. Now, if you see, there is a clear hierarchy. Now, hierarchy helps people to consume the information faster and more meaningfully. Now, if there is a designer creates a canvas and dumps all the components without their own hierarchy, maybe he put all the charts here and at the last maybe KPI. So this is not a good user experience. And what will happen is people will start neglecting this app. They will never use this app. And it's not just about hierarchy. So let's say here the designer has put 48px, maybe somewhere he has purchased 12px. So if you see, even these structures are all bloated. That's inconvenient. So the transformer adds position signals, so it can tell like this is my first token, this is my second token, and that's what makes a huge difference. Now let's take an example, run this. Let's again take two sentences like dog bites man. This is my first sentence. The second sentence is man bites dog. Now what you see here, fundamentally this sentence have the same words, but what inherently differentiate is the position of the words. Now if the LLM can't figure out how the words are positioned, then it will never know how it has to respond. And a very important lessons for designers who are actually getting ready for the future ways of working, which is being a design engineer, is think of your prompt like an UI. If your instructions are scattered, your agent will behave scattered. This is the reason why I've been emphasizing a lot about having good clarity on what you want to do. And once you have a good clarity, the articulation of your thoughts in a structured way so that agent can take as an instruction and do it on behalf of you. So we can take a small example. Like I'm just gonna write a prompt which I've seen most of the junior designers have been writing, and since we teach a lot of junior designers, we've seen like they write something like this: make a user flow. Also keep it short, also explain cases, also focus on mobile. Also I want for onboarding, also don't use too much text. Now if you see this, it's one of the worst prompt that you can ever see. What it says, like, see the structure. It says like user flow, keep it short. Also explain the edge cases, focus on mobile, on onboarding, don't use too much text. I can't figure it out. I mean, if you just give this prompt to me, and let's say I'm an intern working for a senior designer, I have literally no idea what I had to do next. I'm confused, and I'll be just thinking, maybe this guy just want me to create something, and I'll be scared because I'm a junior and this guy is gonna yell me. And now in LLM case, it has no emotions, but what it will do is, because it has to satisfy you, it'll start putting up some gibberish content here, and then you will start blaming and the LLM that, oh, it's so bad, it can't do. But if you want to make this itself a really good, then I would just say the same intent. And if we want to create a better prompt, just structure it. And the structure doesn't has to be like there's a format to do that. People have been explaining about their certain format like role, context, and round, but you can just give a nice articulated thought to the AI and it will still be able to do that. Often then what we do is we just use the voice mode. So your clarity and articulation is the key skill that you need to have in the upcoming work. But even if you want to structure this in this way, you can just write bullet points. Who is asking you to write the long paragraph? You can just be creative around like, so if there's a goal, like I can clearly see like this person is saying about mobile. So I can say like, hey, your goal is to create a mobile onboarding user flow. See? So I've given a goal. The second I can say like, okay, who could be the audience for this? Because you're asking me to do certain research. So I can say like, okay, think about the first time users. Then I can think about what are the constraints I can give it so that it is within that boundaries. Like I don't use too much text. So I'll just write like minimal text. But you should also understand too much text is vague. It needs to be measurable. The LM doesn't understand what's too much text. For a thesis, it could be like 30 page could be a too much text, or it could be one para also could be a too much text. You can just say like 5 steps max. So then you can define like edge cases around this, like user skips permission or weak network. And what kind of output do we expect? We can say like it could be numbered steps plus on-screen note each.
So, Jackie, let's just talk about self attention, which is a key aspect of transformer architecture. Self attention is also called multi head attention, and let's discuss how it works. And knowing this concept will help us understand how good prompts yields better results.
Right. This is a key concept which we've also talked before. You can think about like multiple attention systems that are running in parallel. Think about this, like each system learns to focus on different relationship. Like for example, who is doing what constraints matter, which tool to use, what format is expected, and what's an example versus instruction. So you can just imagine like there are like 7 or 8 people who are reviewing the same prompt, but they're trying to focus on different aspect of this prompt. They're not trying to argue each other. At the end of the day, they just merge instantly. Think about this. So now what happens before when we used to go for design reviews, let's say Figma. So we have one person who might be looking at the layouting. There's another person who must be looking at the content. There's the other person who might be looking at the interactions. Basically, all of them looking at different areas and they instantly merge and make this better. So self-attention is something around this. So the same, it looks at different relationship of the prompt. One of the head could watch the goal, like what are we trying to achieve? For the constraint, there must be like, well, we must not break. Everything happens in parallel. It's not a sequential, that's why they're so fast. What happens is, so if your prompt doesn't clearly separate those information, your multi-attention heads get confused. This is the reason why we have seen in the example, like if you just do a messy prompt, so these attentions are not able to get the different aspect. But if you structure it better, if your articulation is good, this attention can easily know, okay, this person is saying that this is what I want to do. So this is a really important point for design engineers or the designers who are transitioning to the new ways of working. You're not just writing prompt anymore. You're basically designing the context. Start structuring your prompt like a system. Like think about putting the goals at the top, because the system will start referring them at constraints so that the model can be confined within certain boundaries. You can start defining more context around users, around systems, define more tools. If it's an agent, you can also think about skills, think about more examples so it can refer. And of all, start defining the output format in the way you want. If you start defining in this structure, it'll help the multi-head attention, aka the self-attention, to distribute the job cleanly. Now, this will be really helpful, and I can assure you that you'll be getting 100x more better output from collaborating with agents, especially when you do vibe coding. So this will really help you in getting the desired output in single shot. You'll be saving a lot of tokens. We know like the cost of tokens and how we should use smartly and preserve our tokens. And of all, it will be saving you time.